Welcome you all. Myself Mr. S.S. Mahamuni, Assistant Professor from the Department of the Pharmaceutical Chemistry, Satara College of Pharmacy, Satara, affiliated to Dr. Babasaheb Ambedkar Technology University, Lonere. Today we are going to see the practical of instrumental method of analysis from the final year B Pharm. The lecture number is 8, that is determination of the sodium by flame photometry. So we'll start with the first, that is the aim. So aim of this experiment, that is to estimate the amount of sodium chloride present in a given sample by flame photometry. The next is objective. First is to understand the principle of the flame photometry. Next is to understand the instrumentation of the flame photometry. Then we start with first principle. So what is principle? So it is a well-known absorption that several elements like sodium, potassium, calcium and barium, when burned in a flame, emits a characteristic color. So each and every component from that made sodium, potassium and calcium have to emit a characteristic color, so that the intensity of this color varies with the amount of a quantity of an element introduced into the flame, so that the method of quantitative determination of a particular element using the flame photometry has been developed, and it is known as a flame photometry. So it is an example of the emission spectroscopy, and it is called as a flame emission spectroscopy or flame spectrometry. Then when a metal or its a salt is introduced into the flame, light characteristic of the metal emitted. So since the emission of a light takes place at a definite wavelength and the intensity of a light emitted is proportional to the concentration of the metal causing the emission of the light. So the observed wavelength gives us information about which metal is present, and measured intensity indicates how much of the metal is present. Means intensity of specific measurement of indicates the how much amount of the metal present in that, and color intensity also gives emission of the light, also gives the information about which type of the metal present in that sample. So both qualitative and quantitative analysis can be done by flame photometry, and the alkali and alkaline earth metal which have low excitation energies are elements most commonly analyzed by the flame photometry. So we'll move towards the next point, that is the requirement. So glasswares, in that volumetric flask, pipette, beakers, measuring cylinder, funnel and conical flask, etc. are required. The next requirement is chemical, in that sodium chloride, distilled water, stock solution of sodium chloride in 1 mg per ml. Then next is the most important thing is the instrument, that is the flame photometer. So this is of a flame photometer, and here is the sampling we can done. Here is the keys are there to add set all these sample and their different types of dilutions, and that display the observation on that screen. So this is a pumping system where we use a proper flow of the pumping here to get the proper flame photometric instrumentation. Then next is the procedure. So for the for the construction of the calibration curve. So this is also one of the method by that we can find out the unknown concentration by the calibration curve method. So initially switch on the compressor, and knob is adjusted to 0.5 kg per centimeter inverse, and the gas is kept on a open the gas knob and leaned the flame and adjust the meter reading to 0 by distilled water. Then we accurately take 100 mg of the sodium chloride and dissolve in 100 ml of the distilled water to get a stock solution of 1 mg per ml or 1000 microgram per ml. From this prepare different dilutions like 20, 40, 60, 80 and 100 microgram per ml of the NaCl. So we will see afterward how we can prepare in next part. So adjust the meter reading to 100 division by spraying 100 microgram per ml solution. Now introduce the remaining solution in a specific order and record the meter reading. So first of all we want to do what? Highest reading we take we want to take highest reading on that instrument. Then we start with our first reading. Then enter the value in a tabular form in a data that is flame photometer versus the concentration and construct the calibration curve. For the analysis of unknown sample, so introduce the given unknown sample into the flame photometer and measure the meter reading and find the concentration of unknown from the meter reading for unknown and calibration curve. So this is the process for the dilution. So first of all we want to do the stock solution, that is 100 mg. We want to NaCl dissolve in 100 ml of the distilled water. So it becomes forms the 1 mg per ml solution or 1000 per ml 1000 microgram per ml solution, which is stock solution. We use this solution for the further preparation of dilution. So strength of the solution becomes 20, 40, 60, 80 as per the procedure up to 100 microgram per ml. So we want to take a 2 ml from the stock solution. So calculation becomes what? 100 is the strength of the stock solution into 20 is the we want to make a concentration, that is 20 microgram per ml. So that we divide this with the 1000 ml, so it will give 20 microgram per ml. As per this we prepare all this dilution. Then next is observation. So first we get observation for 20, then 40, 60, 80 and 100 microgram per ml, and it will give the flame photometric reading. So unknown we also get this reading, and afterward we putting all the information in a particular calibration curve method, that is preparation of calibration curve. In that case we put the value for the preparation of calibration curve, that is x-axis is for the concentration, y-axis is the flame photometric reading, and it will form such type of the curve. Then we draw the line in between, in between 2 points. It is the goes from the line of origin, and afterward that we draw the extrapolating the value of the flame photometric reading for the 10 with the 10 microgram per ml. So this will give the information about unknown concentration by the calibration curve. Already we discussed this part in our earlier calibration curve method of different types of the instrumental method for the determination of concentration. So also we can done the calculation by theoretically, that is theoretical yield we can 100 into 1 upon 1000 is equal to 10 microgram per ml. So these are the references we have used, and thank you all of you. We will get the result, that is the concentration of the unknown sample which contained sodium chloride as a metal salt. So thank you all of you for the patience of listening.